cloves. We're going to add half water to it, and I'm even going to be a little inventive. I'm going to add a stream of water in here. So you know we have this reservoir of water here. I'm not going to do that. I'm just going to add a little tube of cold water and send it through here so that I can increase the oil, which is heavier than water, is going to condense down at the bottom below water. And so we're going to use methylene chloride to extract it out, okay? So I need someone to grind down those cloves. I need someone to, and when it does, it's going to boil and everything is going to heat up. This is going to get really, really hot. And as soon as the vapors touch this like cool jacket here, it's going to start condensing, and then hopefully it's going to run down. But we have to have this down healed. This is going to take a while, so you can sit chat.
So you're going to Berkeley?
Yeah, I'm there now. I teach there on Mondays and Wednesdays, right after this. So I have to learn. Now the other thing you'll notice about colligative properties, not only do you lower the boiling point of the cloves oil, the eugenol is supposed to, boil at 250 degrees, but now it's going to cold still with water. But water's boiling point also depresses too, so it will boil. That's why the thermometer was really nice and key for here, because you can start to see that water and the clove oil starts to distill about 80 degrees. It really depresses quite a bit. That works for that works to our advantage when you're in natural products chemistry, because you can always get the product out either by co-distilling it with water or in ethanol or the organic acid. So when I was, right after I graduated from San Jose State, I used to take my little brother to my lab where I worked, and they had these nice eucalyptus trees all around. And I love eucalyptus trees because, the trees, I'm an artist too. I like to paint, and I like to do like very abstract art. I would take the bark from the eucalyptus tree, and I would like paint a canvas with some background, whatever color, and then I would glue on, soak them in acetone, and then we would just let it dry. And then I would put like little towels down, like little strips of canvas on the picture frame. So not only did you see the bark from the tree, but you can smell it as well. So that was fun. I do those types of things with my kids too. We do roses and sometimes eucalyptus or whatever. Yeah, if you soak it in acetone and then you have like a little cheesecloth in it, you can filter the leaves, then it will give you the essence of eucalyptus. And it helps with your bronchial dilation, and you dilate your bronchial tube so you can breathe really nicely. Okay, so you can see here it's starting to condense, right? It's boiling here. If you touch here, it's really hot. And now it's sort of refluxing down. You can see that it's coming up and coming down, coming up and coming down. When the heat gets all the way here, it's going to start condensing like it is right now. When it starts touching this cold water, there. And you see it's a thick, oilish oil. So like it's not quite water, or it's just like an opaque color. That's the oil coming out of the cloves. You see that? See the color? It's like a pale white.
Wait, that's entire thing's full of water.
Huh?
This entire thing's full of water.
Yeah, the jacket is filled with water, so it's two compartments. Yeah. Yeah, because the water would be coming out of here, right? That was coming around. So then, I could be a little sleazy. Oh, I forgot. Okay. It's not going to come out of this. It's going to
Block or something?
Well, yeah, you see. There's a little tube inside of the tube. I needed an adapter to go through to drip down like that. This is what I needed. Whatever. Nonetheless, you can still. Yes.
Yeah, you can put on.
Oh yeah.
So we're taking the oil out of the.
Yep, so all of what you're seeing here is the cold distillate of these guys, of eugenol. Oh, I guess we didn't do this. We weren't going to do this experiment. We can. That's easy to do. If we did this transformation here, you would get more peaks on your IR spectrum. You would see this benzene ring and this benzene ring. You would see this carbonyl functionality and everything else. So what we're collecting is eugenol here.
So we're not doing the derivative?
No, we're not going to do the derivative. We weren't going to do that even if we did it in the normal setup because that experiment requires benzoyl chloride, and I haven't talked about synthesis yet, so we'll use benzoyl chloride later on.
Okay.
So now, this will be it also. Yeah, so I added it here. Okay. Because it was starting to boil out. Yeah, the reservoir would keep filling is heavier than water. Okay. We won't see that until we add our solvent. So in about 5 minutes, I'm going to add the solvent to it so that you can really see the difference between the two. We're going to use this. You'll see. This is a separatory funnel. And you see how it's big at the top and it cones down at the bottom. It just reduces down its volume. With these types of shapes, you can really see the difference in the layers of organic. Yes. It's just going to give you more of the. Some more. That's fine. You're still smelling, right? Organic or aqueous?
Organic.
Huh? It's aqueous. Because it did not, it stayed in the aqueous layer. All of the organic material is going to distill with water because we're reducing its boiling point. We're reducing the boiling point of water and then we're forcing it to condense down in this condenser, okay? So all of the aqueous, you can leave it there for just a second. All of the aqueous stuff that just does not go into organic material is going to stay in the aqueous phase. Now, unfortunately, I got a little bit of that here inside of my organic phase. So what I'm hoping for is when I put my organic material in here, I'll have 2 layers, one brown layer and one clear white layer. Okay, let's see. Now you can see the layers very distinct. Okay? And that's what this thing does. This is called the separatory funnel. You will be tested on this. This is going to be on your exam. So these are separatory funnels, and they separate your aqueous layer from your organic layer. Okay? And the way I'm going to do that is by taking an Erlenmeyer flask, and see, I'm just going to open it, and I'm going to let it flow out until that layer gets all the way down here, and then I'm going to close it. Okay? Now, here we have our eugenol, okay? Okay. Catch the organic phase or separate the 2 phases. And sometimes you're left with a small amount of aqueous inside of your organic layer, just like I just did. I just put a little bit in there. You see it floating around at the top? To get rid of that, we have to use a salt called a sulfate salt. So sulfates, sodium sulfate or magnesium sulfate salts, they're sponges for water. They form a nice hydration, water can form a nice hydration shell around the sulfates. And so generally in organic chemistry, what we will use to get rid of any of the aqueous material is a sulfate salt. That would be sodium sulfate or magnesium sulfate. It's a powder, and it forms, you see how it gets really rocky at the bottom? It absorbs the water. Here, you want to take the equivalent of water is generated. So if water is generated, it goes in between an equilibrium between your imine and your amine. And so you can never really get your full amine out of that system. So we add magnesium sulfate, we add this other substance called TMOF to it, we add molecular sieves. All of these water sponges we can add to our reaction mixture just to get rid of all the water that accumulates in the reaction. Okay. All right, so now we need to filter it. So I need a filter. Usually they're here. I don't want to use that one. I want to use. Okay, can someone, ouch, here. Okay. I like these filters because it's all inclusive. You have a septa and you have your filter in there. And all you have to do is just clean it with acetone, and most times it's really clean. Okay, what I need is a thick. I'm gonna filter out my sodium sulfate. It's very important to know where your compound is. Some people will take your white magnesium sulfate and say, oh, this must be my product. No, it's not your product, right? And then if you look here, you see these little brown chips. And a little pipette. Pipette.
Just talk more about it.
No.
No.
So what I need to do is, can you grab that vacuum for me? Thank you. Yeah, on the other side. You gotta walk over there, sweetheart. It boils at 30 degrees, 37 degrees. And so what I'm doing is I'm blowing air on it just to increase the surface area. All right, so let me have this. So I'm going to change the tube, yeah. So I'm going to blow air here to blow it down because I need to have it. Okay, so when I run the IR, what I need is I need to run a blank of the methylene chloride. And then I need to run the sample because the way the instrument works, it subtracts the background. So whatever solvent that I use, I need to subtract it out.
Once you get deeper in there?
Yeah. So I'm going to reduce this volume down to almost nothing. And when I get ready to run the experiment, then I'll just add all the solvents that I need. Okay. And you can feel here, even though it's in the sand, it's still cold because what it's doing is heat transfer. As I add heat, it's absorbing the heat from the sand, and the solvent is being heated up and it's evaporating at the same time, and I'm just blowing away the evaporated methylene chloride. But you can feel here it's like ice cold even though it's in the hot sand. You feel that? Yeah. All right, it's almost done. Someone was like, yeah, it's almost 3. Yeah, we need to get out of here.
We got 2 more.
Like, listen, he was like, yep, 2 more minutes. Hurry your ass up. Now, when all of the methylene chloride is done, you're going to see just straight up oil here. You see how the oil, it was, now this is the true color of the oil. You see that?